Welcome back. Today we are going to continue talking about equations of lines. And today, instead of graphing and doing what we did in the last video, we're going to learn to actually write the equations. And all we need to know to be able to write the equation of a line is the slope and a point on the line. So we're going to jump right in, writing equations of lines. It says, what is an equation of the line that has slope 3 and y-intercept of -5? Well, we can go ahead and use the slope-intercept form of the equation, which is y equals mx plus b, where m is the slope and b is the y-intercept. So now it's just a matter of substituting. 3 is the slope, so m will be replaced by 3, and our y-intercept was -5. And then just to simplify this, we always want to have just one sign. We don't want plus a minus or minus a minus. So we're just going to write that as y equals 3x minus 5. What is the equation of the line that goes through this point and has the slope 2? Well, again, using slope-intercept form. Oh, excuse me, we're going to use point-slope form on this one. And this one we're going to do y minus y1 is slope m times x minus x1. Make sure you use your parentheses around your x's. And so here we're going to substitute in -1 for x1, +5 for y1, and the slope m is 2. So just substituting the numbers, we get y minus 5 equals 2 times x minus a minus 1, and then just cleaning that up a little bit, we get y minus 5 equals 2 times the quantity x plus 1. Here's a chance for you to try 2 on your own. Go ahead and pause the video, and I will give you your answers when you get back. All right, I hope you gave those a try. On the first one, let's go ahead and use the slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. So y is equal to, in this one, they tell us our slope is -1/2, so we're going to write -1/2, and then times the quantity x plus the y-intercept is 2. Sorry that this is so crooked here. I'm having a little bit of trouble with my Smart Slate. So that's going to be a little bit ugly, so sorry about that. Y equals -1/2 times the quantity x plus 2. Let's go ahead and try the last one. What is an equation of the line that goes through that point with slope -3? Well, in this equation, we'll use the one that we have right above here. We're going to do y minus the y-coordinate of the point, which was 4, is equal to the slope of -3 times the x-coordinate, x minus -1. So we just need to clean that up a little bit. So we end up getting y minus 4 is equal to -3 times x plus 1. And that should be the equation of your line. Using 2 points to write an equation, what's the equation of the line at the right? It says calculate the slope. Well, we have 2 points here that are on our line, 3, 5, and -2, -1. So our first step is to go ahead and calculate the slope. And the slope of this line, m, is equal to the difference in the y-coordinates. It's going to be 5 minus a -1, and we're going to divide that by the difference in the x-coordinates, 3 minus a -2. So we end up with 5 plus 1, which is 6, divided by 3 minus a -2 is actually 5, so our slope is 6/5. Use the coordinates of one point in the point-slope formula. So you can pick either of those points. It doesn't make any difference. So I'm going to do y minus the y-coordinate, I'll choose 5, is equal to, and then my slope was 6/5, and then my x-coordinate for that same point is 3, and so that's what our equation would look like in point-slope form. What is the equation of the line in problem 4? That's the one from the last slide. If we go ahead and use the -2, -1 instead of the 3, 5 point, and then for part B, we'll rewrite the equations in slope-intercept form and compare them and see what we can find out, what we can conclude from that. So for part A, what's the equation if we use the other point? Well, it turns out the slope is the same. We can start from that point. If we use the point -2, -1, we end up with this form. And this is our equation, which looks a little bit different from the last one. So if you look back on the last slide, that's not the same equation. It looks a little different. But when we do the second part here, where it says rewrite the equation in problem 4, so I have this part right here, okay, I have the exact same equations written. So this one was using the second point, and then this is from the last slide. So there are our two equations, and it says go ahead and write those in slope-intercept form. Well, if I do that, I get y minus 5 equals 6/5 x. See if I can write this nicely. 6/5 x minus, and then when we multiply the 6/5, we get 18/5. 6 times 3 gives us our numerator. Now we need to add 5 to both sides, so I want to add 5 to both sides here. So 5 on the right hand side, if we want that in terms of fifths, that would be 25/5. So we can add those fractions. And our 5's cancel here. And we end up with y equals 6/5 x minus, and let's see, we had 25/5, so that's actually going to be a plus, right? And we should get 25 minus 18 is 7/5. Kind of sloppy, sorry about that. And then on the right hand side, using this equation, we end up with y equals 6/5 x, and then multiplying through we get plus 12/5. Well, it doesn't look the same yet. Whoops, I forgot my plus 1 here. It's still y plus 1. Sorry about that. Let me go back and just erase that. That's kind of messy. See if I can do a better job for you here. Alright, so let's try that again. Y plus 1 equals 6/5 x plus 12/5. Alright, so now we need to subtract 1 from both sides, and so on this side, instead of saying minus 1, I'm going to write it as minus 5/5. That'll just make life a little bit easier. We can subtract the fractions a little bit quicker. And then on the left hand side, the 1's cancel. Plus 1 and minus 1 add to 0. So we get y is equal to 6/5 x, and then plus 12/5 and minus 5/5 ends up being a plus 7/5. So now if you compare these equations right here, they are exactly the same equation. When we put them in slope-intercept form, you can see that they are exactly the same equation. Writing the equations of horizontal and vertical lines. We started off, it says you know that the slope of a horizontal line is 0 and a vertical line is undefined. So all horizontal and vertical lines are easy to recognize their equations. It says what are the equations for the horizontal and vertical lines through 2, 4? Well, for the first one, let's look at the horizontal line that goes through 2, 4. All of the points on this line have y coordinates equal to 4. So if it's a horizontal line, it will have the form y equals and then whatever the y coordinate is. All of them will be y equals, okay, for horizontal lines. So that's something that I'd like you to just try to remember, or find a way to remember that. It's always going to be y equals for a horizontal line, okay? For a vertical line, all of the coordinates have x coordinates equal to 2. So you can see all the x coordinates. You have 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. It's always 2, so the equation of that line is just x equals 2. Now similarly, all vertical lines will have the form x equal and then whatever the number is. So all vertical lines will have x equal the number. Horizontals will be y equal to the number. What are the equations for the horizontal and vertical lines through 4, -3? Well, remember we said horizontal lines have the form y. Whoops, I need to get my pen here. Sorry about that. So for part A, all horizontal lines have the form y equal to whatever its coordinate is, -3. And all vertical lines have the form x equal to whatever the x coordinate is. For part B, can you write the equation of a vertical line in slope-intercept form? And the answer is no. Well, of a vertical line. So a vertical line is like this one. This is a vertical line. X equal to 4 is a vertical line. So the answer to this is no, because there's no y coordinate. Okay? So that cannot be done because there is no y coordinate. So it's not even in the equation. And we'll see you next time.